Hello.
Good morning, sir.
Good morning. Good morning.
Good morning, sir.
Good morning, sir.
Good morning to all of you. So, what experiment we did last lab? Second or third? I think. Have you guys done the second and third experiment? That is second experiment of the assignment and of manual 2 and 3. Normal PN junction diode and Zener diode.
Yes, sir.
Okay.
Yes, sir.
Now let's move on to the third experiment of the lab assignment. That is study the half wave and full wave rectification using diode. Okay, so this is experiment number 4 in your lab manual, but we have done 2 and 3 in one lab, and we have also combined the second and third experiment. So in this experiment, our aim is to study the operation of diode rectifier circuit and draws its input and output wave shape. Okay, we will apply some input and then we will observe the output. The apparatus that we require is one PN junction diode, and the number of diodes will be 4. One step down transformer with its center tape, and one breadboard to mount different components, one DSO or CRO to analyze the waveform, to observe the waveform, one AC voltage source, and few resistors and jumper wire. Okay, so theory, I think you all of you know what is a rectifier and how we can design different circuits with the help of diode to make half wave rectifier as well as full wave rectifier. Now, in the half wave rectifier, the simplest form of rectifier it is, we have simply one diode right here, and we have connected one resistor in series with the diode. We will take the output across these two terminals, and what we will apply will be an AC input as shown in here. Normally, in what supply we get in household is 220 volts, but we have to step down it that we can apply the input within the range of the diode specification. So we will step down the input voltage, then we will make connections like this. Then we will connect one probe at this point of DSO and one probe at this point to another, this second knob of the DSO. And from there we will get the input signal, which is like this. Similar to that, to the second channel of the oscilloscope, the one connection will be made here, second will be made here, and what we will get will be the output like this. So you can see that the input waveform will be your sine wave and your output waveform will be pulsating DC. Means it is changing, but still it is DC. And during the half wave rectifier, only one cycle of the input waveform will be present in the output waveform, which is positive cycle. and the negative cycle which is present in the input cycle, that will be absent in the output of the half wave rectifier. So this is a simple half wave rectifier circuit. Similar to that, we will have the full wave rectifier circuit. And in full wave rectifier circuit, we will design the center taped rectifier circuit. Here we have two diodes connected like this to the two terminals of the secondary coil, and at the center of the secondary coil of the transformer, we will connect the load resistance RL, and we will make connections like this. So we will apply in AC input at the primary coil of the transformer, and we will observe output from the across the load resistance RL. Now this is a circuit for full wave rectifier, because during the positive half cycle this diode will conduct, and during the negative half cycle this diode will conduct. But during both the cycles, the current that will flow through the load resistance will be in this direction. So that's why we get positive half cycle as well as negative half cycle, but in the output we have both these cycles in the positive direction. So that's how the full wave rectifier works. So we will make connections like this, and then we will observe the output. Okay, now you should know all these terms. What is average load voltage? That is VDC. This is generally comes out to be Vm by pi, where Vm is your peak voltage. And this is the derivation that you have to do, that you may have already done in the class. Then is the peak inverse voltage that is experienced by the diode. Now in this case, the peak in half wave rectifier, the peak inverse voltage that diode can have is Vm, that is peak voltage of the input signal, which is shown here. Similar to that, we can also calculate the RMS value of the voltage across the current. That comes out to be Vm by 2. Now, when we observe the output of the half wave rectifier, we can see that it is not completely DC, and it has some AC content in it also. So those are the ripples. And how to find out the ripples? For that, we have this formula, ripple factor, which is equal to Vrms by Vdc. So Vrms is your Vm by 2, Vdc is your Vm by pi. So you can calculate from here ripple factor also. Okay, so these will be the observations that we'll be observing. And now let me see if Mr. Vijay is here.
To write this on the lab manuals, right? It has to be handwritten.
No, it's okay if you can write in the Word file. That's also fine. You will be designing the circuit in the multisim. You will taking the screenshots there, importing images. So you can.
Okay. And we have to name this as experiment 4.
Yes, you no, just name it experiment number 3. अगर आपने पहले experiment number 3 के नाम से अलग separate file दी है, तो name it experiment 3 new.
Okay, sir.
Okay. So I think you guys know both the circuits. You don't need to see the diagrams again and again. Now I am moving to the multisim part. And you guys also open your account on multisim. And design the circuit on your own. I will help you only if you guys have any problem. to design this circuit in multisim. I will ask you guys to share the screen, and then we will see if there is any problem in that.
Like this, right?
Hello? Yes?
Like this on right?
Your voice is
Uh,
not audible.
hello.
Hi, now it's clear.
Yeah, like this on right? We have to show the circuit, right?
Yes. Have you done it?
Yes,
Okay. Let me stop
there's a
sharing
video now.
my. Yes, it's visible. What is this 12 volt?
So yeah, this VDC, what do I need to do? And is this connection all right? That's what I'm getting confused at.
No, no. You don't. You have to do only the AC part. You have to apply the AC signal at diode D1, and
Okay.
the output across R1 you should observe it with the help of probe.
Okay. Got it. I thought,
Yeah.
yeah. All right. Got it.
So,
Yes,
so can I share my screen?
just a second. Yes, please.
So you have disabled screen sharing.
Now I have changed the setting.
Is it visible?
Yes, it's visible. Why is it showing only one output in the graph? I mean, a green signal is not there for input. Okay. So you can, I think it is correct. If you can somehow change your settings of the graph so it is visible more clearly. Right, not above each other, but ग्राफ में आप ऊपर नीचे कर सकते हो तो इसको देखो जरा कि आपको पहले ऊपर जो है वो ग्रीन सिग्नल दिखाई दे, उसके नीचे जो है वो ब्लू सिग्नल दिखाई दे.
Okay, so I'll just check.
हाँ, ओके, चेक करो सेटिंग में ऐसा कुछ है तो. Okay, so for half wave rectifier, you can simply use this 10 volt 50 hertz AC source right here at the input terminal and observe the output. I have connected a central tap transformer right here, and input supply I have given what we get in the household, that is 220 volt 50 hertz, and then I have set the parameters of this step down transformer right here. So you can see that the ratio of primary turns to secondary turns I have set is 22 to 1 volt, 22 to 1. So that means the output voltage that will be obtained at the secondary coils will be 220 volts divided by 22. So that will come out to be 10 volt AC signal. Now I have simply used the center tap transformer just because I need it for the full wave rectifier circuit. You can simply connect this one also in case for half wave rectifier only. Okay. So by running this, you can check the output in the grapher, and there you can see that only half of the portion of the input waveform is on the is available in the output cycle, and rest of that is not.
So can you show how did you change that number of for that transformer, because it's not showing for me.
You simply double click on this transformer. You will see these four corners highlighted with different operations, and you don't have to click anywhere else. Simply look at the right. You look at your right side, and you will get some description of the component you have selected. There you will find the operation for this turn.
I don't know, showing like this for me, it's showing grayscale, so I can't do anything.
Maybe you have selected this from here document, so you can select the item from here. Sometimes if we click on this setting bar, it gets your right pen is hidden now. So to visualize the right pen, simply click on the settings.
Okay, I'm saying like if I want to select this, and I'm selecting. So can you see the screen?
Just wait a minute. Yes, I'm seeing your screen.
Yes, sir. So when I'm clicking this, it's showing in the item area, but it's all grayscale. So I can't select an option for that. So, and even in document portion, it's
maybe you have not stopped this simulation. Just first stop this simulation only, then you will be able to change the parameters.
All right, all right. Okay, so fully stop it. Okay, got it. Got it.
Yes.
I just paused it actually, so that's why it was getting. Okay.
Yes, yes.
Sir, can I share my screen?
Yes.
Sir, is it
It is.
visible?
Yes, it's visible. Okay, your output is correct as per your circuit, but you have to make some changes in the circuit. The input supply that you have connected is 1 volt, 1 kilohertz. So what you get at the secondary, that is 22 times less than 22, 1 volt divided by 22. If you have set the turns ratio 22 to 1, so that is less than 1, and that's why your output is getting is 0. So the junction voltage across the diode, by default it is 1 volt. So your diode will be forward biased if it is above 1 volt. So increase this input voltage from 1 volt to 30 volt or to 20 volts and 1 kilohertz to 50 hertz.
So,
Okay.
That's it.
so,
Yes.
so can you just check what setting you have to do in graph? Like, is the circuit okay, right? So can you see the screen?
Just a minute. Yes, we can see the screen.
This circuit is okay, right? Yeah.
Yes.
So why I'm getting this type of graph? What setting do I have to change?
Just click on the settings button, the gear
Okay.
button, and now
Yes, sir.
first click on the grapher, graph
Okay.
area,
Yeah.
and now scroll down. Now you can change the limits of the time axis and voltage axis, or you can
Okay, sir.
simply change from the above. You can select the auto or normal mode.
So where's the auto and normal?
In the grapher area, you will see right top right corner. Yes.
Yeah. Okay. So,
Select from
so you
there
did the
auto
auto
or
one.
no. Select auto. Let's see what happens.
Okay. I'm still getting this.
Okay.
Okay, I have to run.
No. Select normal. Instead of
Okay.
auto, do normal. Okay. I think you first have to change the settings of the time axis and voltage axis.
Okay.
So
Yeah.
you can start from 0 to 1 millisecond or any time you can have.
Okay. 0 to 1. And so
Yes.
for voltage, it's okay.
No, you have to change also the settings for voltage. Your minimum voltage is minus 10 or 12 volts, and your maximum is also 12 volts.
Then maximum is 12.
That you have to check in your diagram whether you have taken these turns. What turns ratio you have taken?
Wait, sir. I've taken 220 volt at 50 hertz. I just took whatever was in your diagram actually, so I guess it should be the same.
Just click on the transformer.
Yeah.
Have you stopped the simulation?
Yes, sir.
Yeah,
Yes.
it's okay. Okay, now so your minimum and maximum voltage is at 10 volts. So you can in the grapher you can change them to minus 12 to plus 12. So it will be more
Okay.
clearly visible to you.
Okay, sir. Minus 12. Okay, now I should run.
Now just
Yes,
change
sir.
the mode to
Yes, sir.
normal. Okay.
Yeah. Okay. Okay, sir.
Okay.
Sir, can I share my screen?
Sir, may I share my screen?
सर कौन सा लगेगा?
Yes, you can share the screen. Hello, am I audible?
Yes, sir.
Okay, you can share the screen if anyone wants to.
Sir, I actually am having a problem after Sabi does also.
Is my screen visible?
Okay, I think your input voltage is more than 12 volts. What is the turn ratio you have taken for the transformer?
So
Yes,
it is.
and you have to do it 22. Now it is to 230 volt, then you can also add 23, so your output voltage will be in the minus 10 to 10. Make it 23. Just hit enter and run it again. Now stop it. Go to the normal mode from there, right, top right corner. Stop. Yes, you can do this like also.
Is it correct, sir?
Yes.
Yes, sir. Thank you.
Sir, may I?
Yes. Yes, it's correct.
Yes, sir.
Okay. So instead of writing PR1 and PR2, just change their labels as input voltage and output voltage.
Okay, sir.
If you have done both the circuits of half wave and full wave rectifier, then you can also try the full wave bridge rectifier circuit also, where we have 4 different diodes connected in this particular fashion. The output, your output will be similar to the circuit that to the output that you have obtained in the center tapped transformer.
Sir, we have to try full 4-bridge rectifier or full wave rectifier.
Yes, there are 2 types of full wave rectifier: center tapped and center tapped transformer, and using the bridge rectifier circuit. For half wave, there is only one circuit.
Sir, I am
We'll make circuits for both in that experiment.
Yes.
So we have to take pictures and graph for the both of it.
Yes, yes.
Okay, thank you, sir.
Okay.
Sir, may I share my screen?
Yes.
Sir, can you see this?
Yes, yes, yes.
Sir, graph नहीं सही बना.
Graph is okay. You have just have to change the settings of the display. आप उसको पहले ग्राफर पे क्लिक कीजिए. हाँ. अब नॉर्मल से आप ऑटो कर सकते हो या फिर नहीं, ऑटो में तो और खराब हो गया. आप टाइम एक्सिस और एक्स एक्सिस की जो वैल्यूज है, वो वाई एक्सिस की वैल्यू है, वहीं से उसकी लिमिट सेट कर दीजिए. फर्स्ट यू हैव टू स्टॉप द सिमुलेशन, आई थिंक.
टाइम की लिमिट चेंज करनी है.
दोनों की. टाइम की आप 0 से 1 मिली सेकेंड कर दीजिए. पहले उसको रन कर लो, फिर स्टॉप करके फिर चेंज करके देखो सेटिंग.
अब रन कर दूं सर?
नहीं अब ठीक ऐसे ही रहने दो, 1 की जगह उसको आप पॉइंट 2 कर दीजिए।
ओके।
यस, आप इसी को वो कर सकते हो, सेव कर सकते हो। जस्ट
Okay,
चेंज द
sir.
लेबल्स, इंस्टेड ऑफ PR1 PR2 नेम देम इनपुट वोल्टेज एंड आउटपुट वोल्टेज।
Okay, sir.
ऐसे भी चल जाएगा इसको भी।
Okay. Thank you, sir.
ओके,
Good morning, sir.
यस
Sir, can I share my screen now?
यस यस।
Sir, is it visible?
यस
So when I go for the graph, it shows something like this.
ओके। I think you have connected the ground at the wrong place.
So where do I need to connect ground now?
Just wait a second.
Yes, sir.
सुखमणि,
यस सर।
इस सेंटर टैब में ग्राउंड कहाँ लगाएंगे?
सेंटर टैप में सर मेरे ख्याल से सेंटर पे ही पोर्ट नंबर 2 पे लगेगा।
सेंटर पे ही ना?
हाँ जी।
सेंटर पे लगा के देखिए आप।
हेलो।
Yes, sir.
टाइमिंग्स की सर ने मेरी 0 से 1 0.2 लिया। नहीं।
Okay, just again go to the schematic once more.
डायोड उल्टा लगाया है, D2।
सर ब्रिज वाले में व्हाट इज द वैल्यू? सेम वैल्यू नहीं है वो 220
मैंने यहाँ पे
50
उल्टा लगा दिया था उसको, तो आप उसको चेंज कर दीजिए। जो डायोड आपका नीचे लगेगा वो सेम, दोनों सेम डायरेक्शन में ही लगेंगे।
नहीं अभी भी उल्टा है, डिलीट करके करना पड़ेगा बेटा।
Yes, ma'am. Yes,
Sir, may I?
Yes, someone was asking to share the screen.
Yes, sir.
Yes, you can share it. नहीं आपने click on the schematic.
Yes, sir.
Share your screen again and click on the schematic. Okay, why are you taking three measurements? You only need one at the input terminal and one at across the registers.
Sir, I
Don't-
was taking for okay, sir, I will delete it.
I think delete the blue one.
These two.
Yes. Just
Okay, sir.
जो सबसे नीचे है उसको delete कर दो.
Okay, sir.
Sir, can you see this? Hello?
Yes,
Sir, is
Namit.
this all right?
Yes, yes. Wait, Namit, wait for a few minutes.
Sir, now मैं
Input voltage is not AC signal.
इनपुट
सर
वोल्टेज
इनको
सर
क्लियर नहीं है एक
सर इनपुट
साथ
वोल्टेज
use
के
कर।
लिए प्रोब किधर लगाऊं?
इनपुट की तरफ ठीक लग रही है प्रोब तो आपकी.
सर इनपुट वोल्टेज के लिए प्रोब किधर लगाऊं मैं? इधर
हाँ यहाँ लगाओ
इधर
लेकिन
लगा
वहाँ
दो एक
लगाने
बार।
के भी वही आएगी. एक बार स्टॉप करो.
यस सर.
और टर्न्स का रेशियो क्या लिया है आपने?
सर 22:1.
अच्छा. इसमें जो ग्राउंड कर रहे हो ना वो ग्राउंड आप नीचे कीजिए.
ओके सर.
हाँ सेकेंडरी कोयल का नीचे वाला पॉइंट है
सेकेंडरी को हेयर.
यहाँ पे. हाँ नाउ
यस
रन
सर.
इट. ठीक है. नाउ इट्स करेक्ट.
सर बट ये तो फुल वेव रेक्टिफायर है ना, तो सिर्फ ये तो
तो आई थिंक फिर आपका डायोड कनेक्शन कुछ गलत लगा है. देखो एक बार.
सर पहले आ रहा था, फुल वेव का ही आ रहा था. अब यहाँ पे कोई रेफरेंस नहीं है, शायद इसलिए हो रहा होगा.
नहीं उस टाइम पे आपके इनपुट वोल्टेज जो है ना वो ठीक नहीं आ रहा था. स्टॉप करके देखो एक बार.
सर इनपुट वोल्टेज का पहले प्रोब लगाया ही नहीं हुआ था. शायद इधर एक ग्राउंड और इधर एक वोल्टेज लगा दो सर, शायद तब आ जाए.
करो ट्राई करो.
ओके सर. मैं स्टॉप शेयरिंग स्क्रीन.
हाँ यस यस. नमित यू कैन शेयर नाउ.
Yes, sir. So, in this, ये ग्राउंड और इसके जो वोल्टेजेस का है जो 4 ब्रिज वाले में, तो इसमें अब कनेक्शन देख लीजिए. तो करेक्ट इसकी पोजीशन चेंज कर. एंड सर डायमंड
करो.
शेप नहीं बन सकता तो जस्ट आस्किंग. हाँ सर.
डायमंड शेप वो आपको रोटेट करना पड़ेगा. वो देखना
सर,
पड़ेगा
लेकिन
वो
वो
90 डिग्री के अलावा
बस
45 डिग्री पे भी
हाँ.
रोटेट होता है कि नहीं.
हाँ सर, वो वही मैंने ट्राई किया. इट वाज नॉट रोटेटिंग, सो दैट्स व्हाई. And sir, but ग्राफ में ऐसे आ रहा है. हाँ, wait. हाँ, yeah. तो इसमें फिर सेटिंग चेंज करनी होगी, राइट?
एक बार चेक करो फुल वेव रेक्टिफायर की आउटपुट आ भी रही है क्या?
नहीं, आउटपुट तो स्कीमेटिक में सर आ रही है. ये है ना आउटपुट तो सर, ये यहाँ लगा नहीं लगेगा अक्रॉस द रजिस्टर.
हाँ, लेकिन दूसरी तरफ लगाना पड़ेगा उसको.
दिस पे.
यस यस.
Can I share my screen?
Yes.
तो स्टिल ये ऐसा पार्ट क्यों आ रहा है अभी भी? अब वो कुछ चेंज करना होगा सर सेटिंग्स.
हाँ, सेटिंग में एक बार चेंज कर लीजिए.
ओके, एक बार मैं करके फिर. हाँ.
Sir, is my screen visible?
Yes, visible.
Sir, ऐसे आ रहा है ग्राफ.
जो आपने ग्राउंड लगाया है,
yes,
उसको दूसरी तरफ लगा दीजिए, ट्रांसफार्मर की तरफ. और जो आपने ऊपर सेकंड प्रोब लगाई है PR2, इसकी नीड नहीं है, इसको डिलीट कर दो.
कर दो सर.
यस, नाउ रन इट.
दूसरा प्रोब भी R1 के साथ लगेगा.
तो चार्जर जा ही रहा. नहीं इधर कहाँ
अब आप
लगाऊंगा?
वोल्टेज की रेंज में वो ठीक कर लीजिए, फिर ठीक हो जाएगा, दिखेगा आपको आंसर. ग्राफर में
कितनी कर दो सर?
आपने 10⁻23 लिया है तो -12 to +12 कर दो. एंटर.
यस.
अपने 5 वोल्ट आपने 10 से ज्यादा लिया है क्या? ट्रांसफार्मर पे क्लिक करो. ठीक है. सेंटर टैब है ना, तो वो -5 to 5 में वो हो गया.
ओके सर, थैंक यू सर.
सर.
यस.
सर नाउ में आए.
यस.
Excuse me, sir.
Yes.
Sir, can you please show how to make this bridge rectifier, that circuit? I'm not able to understand how to make it.
Okay. Just wait.
Sir.
Okay, you are taking the input, this blue color probe you have connected to the primary of the transformer.
Sir, you are not audible to me.
Okay, now am I audible?
Yes, sir.
Okay, connect the blue color voltage probe at the secondary of the transformer, not the primary.
Okay,
the
sir.
output of the secondary coil we are applying as input to the circuit.
Sir, when I connect it over here, it shows voltage through this place.
Now, I think now you have the correct output. Just stop the simulation and change the graph setting. जो वोल्टेज की रेंज है उसको आप वही कर दीजिए -6 to +6 -12 to -12 कर दीजिए.
ओके सर. Sir, can you see it?
Yes.
Is it okay, sir?
There is some problem here because your input signal string is not from minus to plus.
Sir, input voltage is not showing because I have connected probe over here. When I will connect probe over here, it will show input voltage. But when I will connect probe over here, it will not show this voltage. This.
Can I share my screen?
Okay, try connecting ground to the secondary. Okay, and okay, someone else also trying to share screen.
Okay, sir.
Yes, share the screen.
दूसरा प्रोब भी R1 के साथ लगेगा.
-12 to +. ठीक है. Enter. अपने 5 बोला आपने इंटरनल से ज्यादा लिया है क्या?
Excuse me, sir.
Yes.
Sir, so that bridge rectifier circuit. Can you
Okay,
please
wait.
show how to make it?
Yes, yes.
Sir, your screen is not visible.
Okay, just wait for a minute. Okay, now can you guys see the screen?
Yes, sir.
Yes, sir.
Okay, पहले आप check कीजिए whether this is correct or not, this diagram. Okay, if you look at the diagram of the bridge rectifier, we are applying the input across these 2 points A and B. and we are getting the DC output across the points C and D. ठीक है, तो हमें जो ग्राउंड है वो तो हमें इसी पॉइंट पे कनेक्ट करना पड़ेगा, क्योंकि जब हम ग्राउंड सी पे यहाँ पे कनेक्ट करते हैं, ओनली देन वी आर एबल टू विजुअलाइज द इनपुट वेव, ठीक है, बट वी हैव टू टेक द आउटपुट अक्रॉस द सी एंड डी, so the reference voltage probe will help be also have to be connected at some place. वो एक बार मुझे चेक करना पड़ेगा, फिर उसके बाद ही मैं आपको बताता हूँ कि ग्राउंड तो आपका पहले यहीं लगेगा, बट जब हम इसको मेजर कर रहे हैं तो वो इन दो पॉइंट्स के बीच में मेजर करने की बजाय यहाँ पे और यहाँ पे मेजर करना है, इसकी रेफरेंस जो है वो चेंज करनी पड़ेगी. डू यू नो अबाउट दिस?
नहीं सर, अभी तक ये करवाया नहीं है किसी और लैब में एक्सपेरिमेंट.
ओके,
तो
ये एडिशनल करा रहे हैं हम.
हाँ जी, अभी तो जैसे अब तक की लैब्स में मैक्सिमम हाफ वेव रेक्टिफायर हुआ है,
अच्छा,
फुल वेव स्टार्ट ही नहीं कराया है.
ओके. एंड इसमें मल्टीसिम में हम जो सेव्ड फाइल्स हैं वो वहाँ पे कैसे जाते हैं?
कैसे मतलब?
जो मैंने एक सर्किट बनाया था वो उसको सेव किया हुआ था.
सर पता नहीं, मैंने मल्टीसिम अभी तक यूज नहीं करा खुद.
अकाउंट में जाने से शायद हो जाएगा.
ऊपर 4 बॉक्सेस ब्लॉक नहीं बना?
कहाँ पे?
मल्टीसिम में जो ऊपर ब्लॉक बना है, फाइल नेविगेशन मेन्यू.
यहाँ पे
आपकी स्क्रीन नहीं विजिबल मल्टीसिम वाली.
ओके, वेट. यहाँ पे
ये से गो टू.
अच्छा, गो टू
माय यस.
ओके, तो अभी तक आपने देखा कि हमने हाफ वेव और फुल वेव रेक्टिफायर बनाया, लेकिन स्टिल जो आपकी आउटपुट दिखने में थी वो आपकी डीसी आउटपुट नहीं थी. उसमें या तो हमारे पॉजिटिव साइड से या दोनों साइड से, बट स्टिल द आउटपुट वाज योर पल्सेटिंग. नाउ व्हाट आई हैव डन इज I have simply connected a capacitor in parallel to the resistor from where we were taking the output. Okay, I have simply connected one capacitor in parallel to the resistor from where we were taking the output. So I have done this to filter out the the AC component, and now your output will look more like DC output. तो यहाँ पे आप देख सकते हो आपके आउटपुट जो है वो इस तरीके से होगी. So this is the output when you use a filter in rectifier circuit. अगर हम यहाँ पे RC की वैल्यू बढ़ा दें, right now resistance value is 100 ohm. If I change it to 1 kilo ohm, then you will see the output is more of DC type. Okay, so this is the output voltage in blue color. Now if I again change the value of resistance or increase the value of capacitor, तो उस केस में भी मेरे जो आउटपुट है वो थोड़ी और ज्यादा डीसी टाइप में आएगी. दिस इज जस्ट फॉर योर नॉलेज कि ये आपको एक्सपेरिमेंट में नहीं करना है, ठीक है. सो नाउ यू कैन सी दैट व्हाट वी आर गेटिंग इज द डीसी आउटपुट वोल्टेज. ठीक है, ये आपकी एसी वोल्टेज थी जो आपने अप्लाई किया, ये हमारी डीसी वोल्टेज है. So if we use some kind of filter in the rectifier, then we can get the exact DC output. Okay, this is just for your knowledge. इसमें ये आप एक्सपेरिमेंट में नहीं करना. तो आप रेक्टिफायर के किसी भी सर्किट में the resistor across which you are taking the output, just connect a capacitor in parallel to the resistor. Okay, now keep on changing the value of capacitor. Right now I have taken 100 microfarad capacitor. अगर आप इसको 100 की जगह 10 लेंगे तो आपकी जो वैल्यू है वो उस हिसाब से थोड़ी सी चेंज हो जाएगी. ठीक है, now you can see that the output is less DC type. इसमें आपका ripple content जो है वो ज़्यादा आ जाएगा. So this all of this depends on the RC constant factor. जो आपकी R और C की वैल्यू होती है उसकी मल्टीप्लाई करके हम एक RC कांस्टेंट की वैल्यू निकालते हैं, विच इज जनरली आप हम बोलते हैं टाउ. जब इसकी वैल्यू कम होती है तभी हमारा जो है वो ज्यादा अच्छे से काम कर पाएगा. द चार्जिंग एंड डिस्चार्जिंग टाइम ऑफ द कैपेसिटर शुड बी लेस. तो वो जल्दी चार्ज हो जाएगा. डिस्चार्ज लेट होगा तो उस केस में हमारा जो आउटपुट है वो मोर डीसी टाइप की दिखाई देगी इस तरीके से. ठीक है. तो पहले दोनों सर्किट बनाने में आपको कोई प्रॉब्लम आई हो तो बताइए. हाफ वेव रेक्टिफायर एंड इन फुल वेव रेक्टिफायर द सेंटर टैप्ड सर्किट.
Sir, can you check once? I'll share my screen.
Okay. Yes, share your screen.
Sir, is my screen visible?
Yes.
So, sir, this is the circuit, and this is the graph for half wave.
Yes, it's correct.
And sir, one more. Sir, full wave, this is the circuit. Sir, is my screen visible?
Yes.
And this is the graph. Is this okay?
But this is not full wave.
So, sir, where is the mistake? Can you please tell me?
You have to connect one more diode in this.
Okay, sir.
You have no. This is not the. This is simply half wave rectifier. But instead of giving simple power supply, you are giving the power supply with the help of a transformer.
Okay, sir.
You have to connect one. Okay. Just look at the diagram and you will be able to design this.
Okay, thank you, sir. Okay. Sir, I'll do it and I'll show you now.
Okay.
Sir, can I share my screen?
Yes.
Sir, is it visible?
Yes, it's visible. Okay, first you have to increase the input voltage. You have taken 1 volt in schematic diagram. Not 220 volt, 10 volt or 12 volt.
Sir, is it visible?
Yes.
Sir, can you tell about graph?
ग्राफ में आप सेटिंग में चेंज कर दीजिए वोल्टेज की लिमिट्स और इनपुट की टाइम एक्सिस की लिमिट्स।
सर कहाँ कैसे?
नीचे आइए, स्क्रॉल डाउन। सुखमणि प्लीज गाइड हर।
श्योर सर। वहां पे देखो ये टाइम है ना, टाइम की वैल्यू चेंज करो, या एक सिंपल आप माउस यूज कर रहे हो, लैपटॉप यूज कर रहे हो?
लैपटॉप।
अगर आपको नहीं समझ में आता ना, तो जहाँ पे एक्सिस पे टाइम लिखा है उसके ऊपर अपना कर्सर लाके लैपटॉप से एक्सपैंड या कॉन्ट्रैक्ट करके देखो। वैल्यू समझ नहीं आती ना, नीचे आओ, नीचे टाइम कहाँ लिखा है? इसी ग्राफ में हाँ, ग्राफ ये इसके ऊपर अब वो जो लैपटॉप वाला है उसको एक्सपैंड या कॉन्ट्रैक्ट करो। आगे पीछे नहीं करना बेटा, पिंच करते हैं ना हम 2 फिंगर से पिंच।
मैम नहीं हो रहा।
नहीं हो रहा, फिर आप वैल्यूज चेंज करो। वैल्यू ये कितनी लिखी है 8.02, इसको 0 से 2 करके देखो। थोड़ा सा टाइम और इंक्रीज कर दो और वोल्टेज को कर दो -12 से +12, या माइनस ये 1 है ना, -1.25 है, -5 से +5 करके देखो। और बढ़ गया। टाइम को करो 1 से 10 करके देखो टाइम को। ये भी नहीं हुआ, 1 से 8.39 है।
हम हो नहीं रहा 10।
0। एक मिनट, सिमुलेशन स्टार्ट करो एक बार। -15 और 5 तो फिर भी नहीं आ रहा है, -5 से +5 के बीच में। आप माइनस
नहीं, ये ब्रिज रेक्टिफायर है, इसमें शायद वो प्रोब वाली कनेक्शन दिक्कत है, इसमें इनपुट वोल्टेज आ ही नहीं रही है माइनस में।
हाँ, एक रेफरेंस प्रोब लगा के देखो रेजिस्टर के अक्रॉस। एक तो प्रोब लगी हुई है ब्लू कलर की वोल्टेज की, उसके साथ ही राइट साइड रेजिस्टर के राइट साइड पे एक रेफरेंस प्रोब लगा के देखो। सिमुलेशन स्टॉप कर दो। ये लगी रहने दो, एक रेफरेंस प्रोब लगा दो।
यहाँ
हाँ जी, रेफरेंस प्रोब अलग नहीं होती है, स्टॉप करके चेक करो। इसमें जाओ, हाँ वो देखो वोल्टेज रेफरेंस ये लगानी है। तो जो PR2 है ना, लेफ्ट साइड वाला रेजिस्टर, लेफ्ट वाली प्रोब, इसकी जगह रेफरेंस लगाओ और दूसरी जगह वो वाली प्रोब रहने दो। वो लगी रहने दो बेटा, ये लगी रहने दो। अब करना जरा सर्किट रन। नेगेटिव में फिर नहीं आ रही, वहां पे भी सर एक रेफरेंस प्रोब लगा के देखें जो इनपुट सर्किट सप्लाई है।
मैम कहाँ पे?
जो ग्राउंड है यहाँ पे भी एक रेफरेंस प्रोब लगा के देखो।
मैम यहाँ?
हाँ जी।
नहीं ऐसा करो, जो आपने ये ब्लू वाली वोल्टेज प्रोब लगाई है PR2, इस पे क्लिक करो एक बार।
क्या सर?
इस पे क्लिक करो PR2 पे, and now change the voltage reference in the panel from ground to reference 1 right here. Yes, अब वो ऊपर voltage reference जिसमें आपका पॉपअप मेन्यू है ground, select this as reference 1. Okay, now click on PR1.
ऊपर
इससे आपको क्या सेलेक्ट किया हुआ है? इसे
ग्राउंड
रेफरेंस 2 कर दो या ग्राउंड कर दो। हाँ, रेफरेंस 2 करके देखो। ओके, नाउ रन। You are not getting the output in negative.
Sir, I have to show my circuit. I've changed
Please
that.
share.
Meenakshi, stop sharing the screen, please. Sir, is my screen visible?
Yes. No. Yes, it is visible.
So, sir, this is sir, ground node is connected correctly.
Yes.
And this is the graph.
Yes. That's correct.
So it's right. Okay, thank you, sir.
Okay.
Sir, we'll write that bridge rectifier in our experiment or not.
अगर आप कंप्लीट कर पाते हो तो ही लिखना। Yes.
Excuse me, sir. Sir, I got the result.
दिखाओ, शेयर करो। Show the schematic. Okay, and click on the green probe. Yes. Click on the green probe, voltage probe. Okay. So you have just changed the reference point from ground to reference 1. Okay, you are not audible. You have to unmute yourself.
Sir, this is right.
Yes. So you have just changed the reference point for green probe.
Yes, sir.
That's correct. Okay. Okay. Yes, that is right. Yes. Just hold for a minute. Okay. So guys, you can see on the screen right now that only one change you have to make in the circuit. You have to take the ground from here, and this voltage probe will measure from with respect to the ground. That you can also check by going to the simulation settings in the right pane, and your green probe should be, that is the output voltage that you are taking. That probe. Am I audible now?
Yes, sir.
Yes, sir.
Okay, so you just have to change the reference point for this knob from where you are taking the output, and then you will get the result. Okay, so instead of applying this transformer here, you can simply connect an AC supply also of 10 to 12 volts.
Okay, sir.
Okay, so that is correct. You can do it anyway.
So
Sir,
next top.
Yes.
so in total for this experiment, 3 diagrams and 3 graphs, right?
Yes,
This
there are
experiment.
3 circuit diagrams and outputs related to all these.
Yeah. Okay. Okay.
So may I share
Okay.
my screen?
Yes. You also have to write something about these circuits in brief, each of the circuits, and also you have to make comments on the output, what type of output we have observed.
So is it
Okay.
Okay, what type of diode you have connected? Okay, just आप एक बार डायोड के ऑप्शंस में से जाके देखिए, बताइए आपने कौन सा डायोड कनेक्ट किया था?
सही है?
Okay, now click on the diode that you have already connected in the circuit. Double click it. And now go to the advanced parameters. Okay, okay, ठीक है.
ठीक है सर.
वो difference हम इसलिए नहीं देख पा रहे because you have connected 230 volt directly. So your
Yes.
output voltage is somewhat less than 230 volt, but it is very less, so it is not visible.
Sir. Can I
So
start?
change it from 230 to in the range of 10 to 12 volt. Now run it. Change settings from जहाँ पे none लिखा हुआ है stop में ग्राफर पे, वहाँ पे नॉर्मल कर दो. या फिर आप पिंचिंग से भी कर सकते हो उसको. अच्छा, आपने सेटिंग भी तो उसमें वोल्टेज एक्सिस पे 500 वोल्ट तक की हुई है ना, इसलिए वो कम दिख रहा है. 15 तक कर दो इसको.
So minus 12 से
-15
12.
to +15. या ठीक है.
ओके सर. थैंक यू. सर आप डायोड्स का क्या बता रहे थे?
नहीं, वो I was simply checking that your output was exactly as per the input. So there was some your output should be little bit less than input.
Okay sir. Thank
That
you.
depends on
Sir,
the
so
junction voltage of the diode. Yes.
sir, in total, we'll submit 3 circuits and 3 graphs, right?
Yes.
All the 3 circuits.
Yes.
Okay, thank you, sir.
Okay. Anyone? Any doubt?
Sir, our next class is about to start.
Okay. Okay. Now I am ending this meeting.
Thank you, sir.
Thank you, sir.
Okay.